In order to solve this equation, the first thing you must do is read the question and pick out the important information needed to be able to solve for the question. The question states, a 75 milliliter solution of HCl with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of a 0.157 concentration of CaOH2. What was the concentration of HCl in the original solution? So the first thing we're going to do is underline the words that we're going to need to be able to solve the equation. These words would include a 75 milliliter solution of HCl, unknown concentration, titrated to the equivalence point, and then 27.3 milliliters of a 0.157 concentration of CaOH2. What we're looking for is the concentration of HCl in the original solution. So the first thing we're going to do in order to solve this equation is we're going to have to make a chemical equation and balance it. So in order to do that, we're going to write out each thing that it says. So we have HCl, so HCl, and that's an aqueous solution. And that's going to be titrated, so it's going to be combined with CaOH2, which is also aqueous. And then when those two combine, you're going to have formed water, which is a liquid, as well as CaCl2, which is another aqueous solution. So now that we have the formula, the last thing we have to do is balance it. So in order to balance it, you're going to need 2 HCl's as well as 2 waters. That way it'll give you 4 hydrogens on this side as well as 4 hydrogens on this side. Now that you have the chemical equation, the first thing that you must do now is to draw your picture. The easiest way to draw the picture is pick out each different solution and draw what it would look like in the water. So the first thing we're going to do is we're going to draw the solution of 75 milliliters of HCl with an unknown concentration. We're going to draw that with a pink pen. So this is our beaker. The 75 milliliter solution, we have to convert that to liters in order to solve. So this is 0.075 liters. And then whenever it's a solution of HCl, but there are 2 HCl's from the chemical formula. And this is all going to break into ions. So we're going to have 2 H pluses and 2 Cl minuses. And this is your aqueous solution of HCl, which is also known as hydrochloric acid. And it has an unknown concentration, so we're going to do M equals question mark. The second solution that we have is the 27.3 milliliters of a 0.157 concentration of CaOH2, which is also known as calcium hydroxide. And we're going to draw that here. Here's our beaker. The 27.3 milliliters also has to be converted to liters, so we're going to have 0.0273 liters of calcium hydroxide. And the calcium hydroxide is also going to break into ions, so we're going to have a Ca plus 2 ion as well as 2 OH minuses. And we're given the concentration for this, so we're going to put M equals 0.157 molarity. And this is your aqueous solution of calcium hydroxide. So now that we have our 2 pictures, we have to figure out how these are going to be combined in order to help solve for the concentration of the original solution. That's whenever we pick out the words that say it's titrated to the equivalence point. This means that this solution here is going to be added to this one. So we're going to draw an arrow, and this is it being titrated. When the solution is titrated, all of the compounds are going to combine together, and when you do that, you're going to get your water as well as your CaCl2. So your OH, your CaCl2, is going to combine to make an aqueous solution. So we'll circle these. This is going to make your CaCl2, and then your OHs, one OH is going to combine with the H plus as well as the other one. So then you're left with 2 waters. And that's how you get your two. So your two products are going to be calcium chloride as well as water. Now that we have what it forms, we're looking for the concentration of HCl in the original solution. So in order to do that, we have to find the concentration formula equals moles over total volume. And the question is asking us for HCl, which is this equation here. But we do not have the concentration of HCl, that's what we're looking for. So we don't have any moles either, all we have is a volume. So what we're going to have to do is we're going to have to use the solution of calcium hydroxide and use stoichiometry to convert it to HCl to be able to solve for the concentration. So how we're going to do that is we're going to use the concentration given to us and the total volume to find the number of moles of calcium hydroxide. So we're going to plug in the 0.157 of calcium hydroxide. Moles is unknown, and the total volume is 0.273 liters. In order to solve this, you're going to do 0.157 and multiply it times 0.0273. And when you multiply those together, you get 0.004281, and that's your moles of calcium hydroxide. So now that we have the moles of calcium hydroxide, we can use the stoichiometry given to us from the balanced chemical equation to be able to convert to HCl. And how we're going to do that is we're going to do 0.004281 moles of calcium hydroxide. And we use stoichiometry. There's one calcium hydroxide, so 1 mole of calcium hydroxide to 2 moles of HCl, so 2 moles of HCl. When you do 0.004281 times 2, your result is 0.0085722 moles of HCl. Now that we've converted into our equation of moles of HCl, we have a moles for this equation here, the original solution. So we're going to take moles as well as the total volume to solve for the concentration of HCl. So again, concentration equals moles over volume. So what we're going to do is do concentration equals 0.00085722 moles of HCl over the total volume of 0.075 liters. When you get these and calculate it, you get 0.114296, and that's your concentration of HCl in original solution. If you're using correct sig figs, when you look back at the original equation, there are 2 sig figs to be used from your 75 milliliters. So your correct answer would be 0.11 concentration of HCl. Some common mistakes whenever you solve this equation would be that many students, they forget to convert your milliliters to liters when you're solving, as well as they forget to use stoichiometry when you're converting from your moles of CaOH2 to your moles of HCl. That's one common mistake, as well as the main common mistake that students make is instead of using your stoichiometry, they use the M1V1 equals M2V2 equation, which would only work if we were talking about the same solution, not 2 separate solutions. Like this one here, it's talking about HCl and CaOH2, so you won't be able to use M1V1 equals M2V2. You have to use the stoichiometry in your concentration formula.